Let's talk about recursion. Functions can call other functions. For example, this main function calls the parseArgs function and the count2 function. But there's nothing stopping a function from calling itself. A function that calls itself is called a recursive function. Now, it might seem like a bad idea for a function to call itself, and it often is a bad idea, but not always. If a function calls itself every time that it's called, your code would run endlessly. Python stops that potentially endless recursion by setting a maximum recursion depth. If we try to call this function that always calls itself, we'll see a recursion error exception is raised. To avoid recursion errors, our recursive functions should always have a base case, which stops the function from calling itself yet again. For example, this factorial function has a base case of 0 or any number below 0. So when we call it with 4, it does actually give us a return value. It doesn't go on forever. When many Python programmers first see recursion, it seems impossible. How could a function call itself? And how would Python keep track of that? Python keeps track of where we are within our code by using something called a call stack. The call stack is what makes it possible for functions to call other functions, and even for functions to call themselves. Whenever a function is called, Python puts a new frame on the call stack. So when factorial was called with 4, Python put a frame on the call stack. And since factorial called factorial again, another frame was added to the call stack. Whenever any function is called, that function call is added to the call stack until that function returns. And each stack frame independently keeps track of its own variables. Once we finally reach the base case in a recursive function, it'll return a value to the stack frame that called it. And that will do a computation returning a value to whoever called it, and then that'll do a computation returning to the function that called it, and so on until finally our original function that we called with 4 returns the value of 24 to us, and then our call stack is empty. The call stack is used for every function call. The only thing that's different in the case of recursion is that we end up with the same function name in more than one place in the call stack. This doesn't mean that recursion is simple. Recursion can definitely be mind-bending, but it's all possible thanks to Python's call stack. Now, most use cases for recursion would be better written using a loop. For example, there's no reason to write a recursive function that just counts downward. We could do that with a for loop instead. Loops are often more readable and easier to maintain than a recursive function. But recursion must be useful for something, right? It is. Recursion is most often useful when the problem you're solving involves traversing or constructing a tree-like structure. Here's a recursive function that navigates a dictionary of dictionaries of any depth. So when we run this function, giving it a dictionary, it will print out the keys and values for every dictionary that it finds. Whenever this function finds a dictionary value that is also a dictionary, it will call itself with that new dictionary and with a new prefix so that it prints slightly differently, showing this indentation below each dictionary level here. This is a great example of a function that would be very challenging to implement without recursion. This is the kind of programming problem that recursion is perfect for. Recursion happens when a function calls itself. The idea is to break down a complex problem into smaller subproblems. It's important, though, that every recursive function have a base case to make sure that the recursion eventually stops. For most problems that involve repetition, Python's for loops and while loops are better suited to the task than recursion. But recursion is pretty handy for certain types of programming problems.